Hello, my CNC brother or sister. I'm Garrett with idcwoodcraft, your CNC router bit supply company. In this video, I am going to teach you how to work with a router bit called a roundover bit. Something I get asked about all the time, and most CNC creators don't really understand how to work with. So what we're going to cover in this video is what exactly a roundover bit is, how it's classified, how you set it up in your design software, how you design a project to get what you want with a roundover bit, and we're going to run a project out on our long mill CNC router here so that you understand everything about a roundover bit. idcwoodcraft.com. So the first thing is, what is a roundover bit, and why is it a router bit that you absolutely want to have in your CNC router bit arsenal? So I have this Home Sweet Home sign that I made up, a very elegant sign. It's got some nice contours to it. When we cut projects out like this, we cut it out and it's going to leave a very square edge on it like that. Well, a roundover bit is going to add that accent roundover to it. And that is what's going to give a project like this the added elegance that you want to have in your projects to make them pop a little bit more, give them a little more character. So we are going to dive into this. I'm going to start off by explaining to you the different types of roundover bits, and then we're going to get into my design software and I'll show you how to set it up, and we will work on a very interesting and unusual project. So let's get into roundover bits themselves first. This is a roundover bit. You can see that it has a rounded contour on it, like that. It comes down to a point, and then it's got a little edge up along there that is also a cutting edge. And so what this is going to do, it is going to cut that little radius out just like we have on the Home Sweet Home sign. A roundover bit is considered what's called a form tool. Now, a form tool is any router bit that has any kind of unique shape. In this case, we got a radius and a straight edge. But if you look at these images here, you can see we have different types of shapes that we can get when we are carving wood. So that is what makes it a form tool. And the thing with form tools is we have to define them in our design software in order to get the software to understand what it's working with. But we'll work with that one in just a minute. So the types of roundover bits are this style here, what we call a pointed roundover bit, which is what I recommend for CNC routers, and I'll explain that in just a little bit. And then we have flat bottom roundover bits, just like you see right here, where this is long flat bottom here. Now these exist so you can get what they call a beading cut. A beading cut is where you can get a radius in it and then you get a little step down like that. You can get a little cut in like that. I'll demonstrate beading with this bit from idcwoodcraft here in a little bit when we actually run out a project. When you're running a CNC router, what you do not want to use is a roundover bit with a guide bearing on it. And the reason you don't want to use that is because this can put undue pressure on your CNC router if it's off a little bit. So as it's running around, that router guide bearing is going to roll along the side of your project, and if things are off, it can put sideways pressure, too much sideways pressure on your machine and cause some stress, cause the bit to break, cause your project to break away, or actually mess up your cut. So for CNC routers, never use a router bit that has the guide bearing on it. You always want to use a straight shank type of bit like this that does not have a guide bearing on it. So this is a roundover bit. This particular one from idcwoodcraft is a 1/4 inch roundover bit. And so what that will do is leave a 1/4 inch radius on the edge of your project, or inside the project. If I wanted to run a kind of an interesting little cut here, which I'll do a little bit later in this video when we run this project out that I'm going to run, we can use a roundover bit to get a kind of cut like that in a groove just like that, and it'll add a little more character. Now idcwoodcraft currently has 2 roundover bits, the 1/4 inch diameter and the 1/8 inch diameter or radius round over bit. It's not diameter, it's radius. The way you determine or call out a round over bit is by the radius that it creates. So this has a 1/4 inch radius, or if you were to draw a circle like that, it would be a 1/2 inch diameter circle, but this is cutting a 1/4 inch radius. So that's the basics of a round over bit. It's a form tool. We have to tell our design software the actual contour of your round over bit or any type of form tool. Now, I'm not going to walk through how to set up a form tool in this video. I've got other videos that talk about that, and I will link them down in the description. For now, we're going to use what's in the IDC Woodcraft database. Now, before we get into this, when it comes to coming up with the form tools and actually designing it and telling your software exactly the contours of that router bit, it can be a little complicated. And that's why I suggest if you're going to go with a round over bit, you just go download the IDC Woodcraft database. The information for this one, this in particular, exists in the database. So when you set up your design, you can use this one, the 1/4 inch round over or the 1/8 inch round over, and just run with it. Now, one other thing I want to explain to you: when you are relatively new in CNC routers and trying to work with a round over bit, I always recommend you go with a pointed round over bit. And the reason is if you are using a flat bottom round over bit, you need to know this dimension here, or the 1/2 dimension, and then when you're designing in your project, you have to take into account that difference and you have to design around it. In other words, you have to take into account this 1/2 distance and then do some offset work when you're creating your CNC router designs. And for newer creators, that can be a little bit too complicated and can walk you into errors in your CNC project. So I always recommend that if you are relatively new or you just want it to be easy with your CNC router, even if you got experience, go with a pointed CNC round over bit as opposed to a flat bottom round over bit. So now we're going to get into the Vectric software, and I'm going to start working with a project, show you how to set it up on a design, and then we're going to run it out on the CNC router. So we are now in the Vectric design software, and we are going to design this really funky looking clock shaped thing with the yin and yang symbol and gear looking type of thing. And we're going to do the outline using the round over bit and the yin yang symbol with the 1/8 round over bit. Just in the middle here, it's just going to add an interesting contour to it, just like I talked about before. So the first thing is we have to set this up so that we use the proper dimensions. Now, what I'm doing here is based on the IDC Woodcraft round over bits. If you're using other brand round over bits, you're going to have to get the specifications from them. The first thing we got to do is carve everything out. Now, we've already carved the clock out on this project, the numbers. The next thing I want to do is start by actually doing the cutout of the outer boundary. Now, cutting out the outer boundary is not totally necessary to use the round over bit. It's just the way I like to do it. So we're going to cut out the outer boundary on this project, and then we are going to do the round over bit. But we're going to assume right now that I have already done that, because when we get to the actual project, it's already going to be to that stage. What we need to do now is actually create the tool path for the boundary for the rounding over of the outer edge. So here's how we start to do this. First of all, I've selected the outer edge of this gear looking thing, and we're going to put a 1/4 inch radius round over around the outside of this gear looking thing. So this would be considered a profile tool path. First thing I want you to understand about what we're doing and why we want a pointed round over bit as opposed to a flat bottom is that we can tell the software to follow that line. We are literally going to profile in the software using the on the line command, so we don't have to offset anything. So in the software, this is a profile tool path. Under tool paths and operations, we are going to select the very first tool path called profile tool path. We'll select that, and then the cut depth needs to be set up. When it comes to the IDC Woodcraft 1/4 inch radius round over bit, there are certain measurements that we have to take into account when it comes to form tools. Now, this is a 1/4 inch radius roundover bit, and that 1/4 inch starts just a little bit lower than the end of the point. This is the distinguishing thing about pointed roundover bits versus flat bottom roundover bits. The flat bottom has a full 100% 1/4 inch radius, whereas pointed roundover bits come down like that and they just slightly don't finish that full radius straight down. So we can't set the cut depth of the roundover bit to get the full effect of the roundover to the top of the radius right up here at the very tippy top right there. If we go a full 1/4 inch depth, we actually have to be just a little bit underneath that. So with this bit, we will set our depth of cut to 0.24 instead of 0.25. And that'll get us almost the perfect radius at the top. So I'm going to set my depth of cut to be 0.24. Now we have to select the router bit. Right now it's set up for a compression end mill. We need to change that to the roundover bit, the 1/4 inch. So we're going to hit the select button and come over to the router bit database. Now if you look to the left of this database, you see this whole entire list of router bits. When it comes to populating your router bit database, there's a lot of time and effort that you have to spend doing that, typing in numbers and trying to understand exactly what needs to be in that database. At IDC Woodcraft, if you go to the website and you go to the top in the menu section, as you see right here where it says download database, then you click that and there will be your database there for Vectric, Fusion 360, Carveco, and Carbide Create. I don't have it available for easel because easel doesn't use databases. So rather than, what I'm suggesting is that you go get the database and get all this information populated, and for things like this roundover bit, you won't have to try to figure out how to design in a form tool. It's already in the database. Everything that you see here is everything in the IDC Woodcraft router bit supply. So what you want to do is come down to the bottom of that database down to where it says form tools, and we're going to click the first one that says 1/4 inch radius form tool. Select that, and all the data is already populated in here for you. And you notice over to the right there's this unusual picture there. That is the form of this form tool that we had to design up in the Vectric software to tell it exactly what that size was. So like I said, if you're brand new, don't try to do that now. It's a little bit more advanced, so just get the database. All right, so we're going to select that tool and we're going to go with the settings that are in it. And it's really important under machine vectors that you select on the line. You see there are 3 selections. It says outside right, inside left, and on. This type of router bit, the pointed router bit, if you want just a clean radius, you need to tell it that you are going to cut on the line. Super, super important. So we have selected on the line, and the only other thing that we have to do is simply give it a name. So down in the bottom it says name. We're going to call this rounding, or we'll call it outer edge round. And then one of the things that I always do when I'm creating tool paths is I give it the name of the bit that I'm using. This particular bit is 14R&D, so we know it's a 1/4 inch round. Calculate it, and now I'm going to reset this tool path and rerun it. So that's what we've come up to so far, is the cutout, the hole. There's a little hole in the middle. I've already done that. We've got the numbers. I have other videos that explain to you how to do numbers and things like that. So we're not going to do that here. We're just talking about the roundover bit. And then I'm going to double click on the outside here, and that's going to make that outer material go away. Now I'm going to rotate, and as we are looking at this, you can see we now have a roundover around this gear looking thing. So that's what we're going to do with that one. Taking a look back at the 2D view, or the design that we did, we have this yin and yang symbol with the little circles here. And what we're going to do is we're going to use the contours of the 1/8 bit just to add that little interesting flavor to this project on the yin and yang symbol. So we're going to set that up as a profile toolpath as well. So what we have to do is close the preview toolpaths, come back to the profile toolpath, and then we're going to select all the items in the yin and yang symbol. So I'm going to select the inner little S part, I'll select the two circles, and we will select the outer circle. And we have to set the depth on the bit so that it cuts to the proper depth, doesn't go too deep. Again, when it comes to the pointed round over bits, it does not come down to the quadrant, the 90-degree quadrant of a circle. It's just slightly short. So with the 1/8 round over bit from IDC Woodcraft, that's the case as it is with all pointed round over bits. So we are going to stay at a 0.09. That's the right depth for this bit, so it doesn't cut down into the sidewalls of that bit. I want to make sure you understand what I'm talking about when I'm saying the round over bit comes down, but it doesn't come down to a full radius. So this is the profile of a pointed round over bit, like that. And there is a center axis going through that round over bit. Because it comes down to a point, we need to have enough material at the point that the point doesn't break. So it doesn't create the full final arc of this 1/4 inch or 1/8 inch, whatever your round over bit is. So at the last edge of this, there's basically an angle like that. So this little bit of an angle is the radius that you're not going to get at the bottom of the cut. And it just has to be like that with pointed round over bits. So that's what I mean by when you don't have the full radius at the very bottom. I just want to make sure you understood how that worked. So I'm going to set the depth of that to 0.09. Now, the way that you're going to know with the IDC Woodcraft database of what the rounding depth is when you go back into the database and look at the data. Now I'm going to show you right here. First of all, we have to change this from the 1/4 inch radius to the 1/8. So we're going to hit the select button to bring the database back up and go down to the bottom to the 1/8 radius round over form tool. Select that and you're going to see a number right here at pass depth. And for the 1/8, the pass depth is 0.095. Now you're going to get a nice little radius on our 1/8 radius, but we have to do that with pointed round over bits. So getting back in the software, with the round over bits, for the 1/8, you just look at the pass depth number for the IDC Woodcraft database, and with the 1/4 inch round over bit, you'll see the number is 0.24. So that's what you'll use to determine the depth of the round over tool. So we have now selected the 1/8 round over bit, hit select, it's ready to go. The next thing you want to do is make sure you are on the line, and then we are going to come down and create that tool path or calculate the tool path. We're going to call this yin, yang, R&D 1/8 and calculate. And then we will preview that tool path. So preview the selected tool path, and there we go. We've got this interesting rounded effect. Now, to me, that's a little bit too strong, so I'm going to reduce that depth a little bit. So we're going to just double click the tool path, reduce the depth to 0.05, and recalculate. Reset the preview, and preview the selected tool path, and there we go. It looks quite a bit better. And let's just preview everything just to see what it looks like. And yes, that looks a heck of a lot better. So now what we have to do is we have to generate the tool paths for these two round over tools. And it's very easy to just do it the same way as you always do any other tool path. I'll walk through it real quick. I'm going to close the preview tool path, and we are going to simply select the last two tool paths. Now the reason I'm not selecting the other tool paths is because I am not covering those aspects in this video. So we're going to select the one with the 1/4 inch round over bit and the 1/8 inch round over bit. So we're going to go to Save Toolpaths, and we have in the Vectric software just those tool paths checked. You can see down at the bottom, there are the only two that are checked. That means that that is exactly what the software is going to write for. It's not going to write the other tool paths. So those are checked. We make sure our post-processor is set right. So I'm using the GRBL inch, which is what's going to work for the long mill CNC router. Save the tool paths, select the destination, and now we're going to call this, we'll call this gear. And we're going to name it gear, and you'll understand in a second. I'm going to click save, and now we're going to go into the directory and check these tool paths out. So you see I have two files here that are the tool paths, and they both start with gear. That's why I named it gear, because when Vectric writes the tool paths, it's going to put the name that you put in the save section of, that's going to be the first part of the title of that file. So you can see the first one says gear 1 outer edge round 14 R&D, and the second one says yin yang R&D, and it doesn't say 18 because I didn't put the 18 in there. My numbers were turned off when I did that. Now all we have to do is load it up in GSender. So I'm going to go over to GSender. Now GSender is the control software that I recommend that anybody uses because it is so user-friendly, and it's got a lot of features in the background that you can work with, and it's for the most part automated. A lot of the other control software you have to do a lot of configuration to. Control software is what actually runs your CNC router, like the long mill CNC router, which is the CNC router that I recommend that new creators start with. It's economical and it's still a very robust machine, and you can do a lot with it. So we are going to come in, we're going to load the file, we're going to do the gear with the 1/4 inch rounding bit first. I'm going to select that, and now you can see there's this one line in there that has that gear shape. That's all we need. Now all we have to do is load up our CNC router bit and make sure our Z0 is set, and that's what we're going to do right now. Oh, I wanted to say this. There's another thing that you can do with a roundover bit that I forgot about that I want to make sure you know about. It's something that's a little bit beyond the roundover. It's called a beading cut. That's B-E-A-D-I-N-G, that you can do with a roundover bit that adds even more accent to your projects. I'll show you at the end of this after we do the roundover demonstration. So the first thing we need to do is change the router bit that's in here to the 1/4 inch radius roundover bit. Now you're going to see a little interesting device here that isn't typical on CNC routers. There's a little screw here. This is something called a muscle chuck, and it is a quick change tool for your CNC router. Now the particular one that's here is specific to the Makita trim router that you will find on many CNC routers. But IDC carries this, and it carries other muscle chucks for other different CNC routers, such as those for ER collets. And here's how it works. You see I got a screw here. I'm going to just put my Allen wrench in there. I'm going to loosen up the muscle chuck, take the router bit out that was in there, and simply put in the 1/4 inch roundover bit, and that's it. That's how fast the muscle chuck is. If you're still dealing with the nut and collet method, then you might want to switch over. You can go to IDC Woodcraft to get the muscle chuck for your Makita trim router. I'll have them available for the DeWalt trim router and for your spindles as well. All right, so we are literally set up. All we have to do is now just zero out our Z in this project. I've already got everything set up other than my Z, and so now all we have to do is carve out this little gear all the way around here. Okay, first what I have to do is quickly, I'm just going to do the cutout of that gear. I'm not going to cover that here in this video because this is about the roundover bit. So you can watch it cut out though. All right, so we have finished doing the round over part for the 1/4 inch around the gear. Now we need to switch over to the 1/8 inch to do the yin and yang feature on the clock that we are carving out. So again, we go back to the muscle chuck and find that screw, get the wrench in there, unlock it, pull our bit out, and then we're going to put the 1/8 bit in. But before we do that, I want to show you what you have to do when you have a 1/8 bit, because in the muscle chuck it's a 1/4 inch shank hole, like most of your CNC routers that you find out there for bench tops. If you put a 1/8 bit in there, it doesn't hold. So that's where we use the reducing collet adapters. Now this is the standard generic collet adapter that you find at IDC Woodcraft, and that will work perfectly. You put it on the 1/8 shank bit, slide that up in there, but I've seen on occasion from some people they accidentally move that collet too far up into the muscle chuck, and then they have to take the muscle chuck off. And that's why we have this. This is a much more precise collet. This is a 1/8 reducing collet, and it's machined at a much higher tolerance. It's made more like collets that you would find in manufacturing, and it's got that little lip on there to make it stop. So you put your 1/8 shank bit in there, bring that up in there just like that, and of course tighten your collet down, your muscle chuck, and that bit is in there nice and solid. And when you need to change your bit, you simply take that out and change your other bit. Now, one of the other things that people ask me is, how do you clean out the muscle chuck? Because you always have to clean the sawdust out of your regular nut collet assembly method. Well, the muscle chuck, that's fixed. You don't take this off. So what you want to do is do what I do. I simply take a Q-tip and get it up in there and clean it out, or you can get a can of air and simply blow up in there and blow out the dust. And then we'll put the 1/8 round over bit from IDC Woodcraft in, and we'll put it in the proper way. Now, when I say proper way, one of the things that I see too many CNC creators do is they put their router bits in improperly. And being brand new, you don't really realize that there is some rules that you need to follow. So with IDC Woodcraft, whenever a new person buys something from IDC Woodcraft, or a first-time customer, they will get this sticker in the package. And it's the proper holding for CNC router bits. And it has all the rules you need to follow to save your CNC router bits from breaking or coming out. For example, you never try to get as much length as you can out of your router bit by just sticking a little bit into the collet. You are asking to break your CNC router bit. So that's why you want to learn, you want to know how to do this. So if you buy something from IDC Woodcraft and you're a first-time customer, you will get this in your package, and you'll have this very, very important information. This is something I've never seen a router bit company give you education on. This is a very important rule to follow. So what we're going to do is put in the 1/8 round over bit, get it in there the proper distance. So the proper distance is the first third of the bit of the shank. And simply get the wrench in there and tighten it up. And oops, didn't. And that's it. We are ready to rock and roll. All we have to do is set our Z on our project piece right here with our touch plate, and we will be ready to go. And now all I have to do is load up the yin-yang symbol. And remember, we're on the yin-yang. It's just a slight curvature that we're creating to create this outline. So I just find it in my G-Sender software, load it up right there. Now all I have to do is turn the router on and hit go. So let's do it. Now, one of the things is you want to make sure with these router bits you are set to about 3 on your Makita if you are going to use a Makita. Remember, the RPMs are already set up in the database, so you can get that information from there. So let's fire this puppy up and let's rock and roll. And there it is. Our little clock face is all done. The blue on here is masking so that I can paint this project. I can paint the numbers, I can paint the boundary, I can paint the little yin-yang with spray paint, and then peel the masking off. So now that we've got this part of the roundover bit done, there's another little tip that I want to show you about roundover bits, and it's called a beading cut. B-E-A-D-I-N-G. Now, a bead is where you actually have a step in your cut. So we have the roundover that's going from the side, and it comes to the top of the project. A bead comes around like that, then it steps up and then goes across the project. So we're creating like a little step in there as well. It just adds a little bit more of an accent. So we're going to get back into the Vectric design software and simply just lower this cut down a little bit, and we're going to come back and make another pass, and you'll see exactly what this beading is all about. So in the Vectric design software, I'm simply going to come back into the tool path for the 1/4 inch roundover bit, and we are going to change the start depth. I'm simply going to add a 0.1. Now a 0.1 is just going to create a 0.1 tall bead. So basically when you're doing your start depth in the Vectric software, and this is a really important tip for you, you have your start depth, which in this case is 0.1, and then we have a 0.24. So the total depth of cut to the end of that point is going to be actually 0.34. So you add the start depth to the cut depth, and that's how deep your cut's going to be. So I've got that in there. All I did was change it to 0.1. Sometimes we want the beading to be a little bit lower. I'm going to calculate that, and I'm going to resave this tool path, and we're just going to call it bead, just to get this done here. And that tool path is done. I'm going to load it into the G-Sender software. I'm going to find that bead right there. There it is. I'm going to load it up, and now all I have to do is get the 1/4 inch roundover bit back into the machine. That part of putting the bit in the video here, just because I've already done it twice. But remember, we got the muscle chalk, a really fast changeover tool, and so I'm just going to run it now, and you can see exactly what it does. So here we go. So now we have made the bead cut, and I want to show you what it is and how it looks. So come on in here with the camera. I'm going to pull this outer piece off, and if you just take the camera down to the side, and you can see now we've got a little step on the project. There's a little bit of a flat there, and that adds a little bit more accent. And if you want more, then you simply go a little bit deeper. And that, my CNC friend, is the little extra tip: beading or bead cuts with a roundover bit. Finally, one thing to be aware of, with pointed roundover bits, you may get this little line here. And that is pretty typical for pointed roundover bits. And you can just get rid of that by sanding that out, or you can actually do an offset from the original line or the final line that's creating the project, and just do a little bit of an offset in the design, and then do your roundover bit toolpath based on that. But you can see we've got a very cool roundover edge on this weird looking yin-yang sign. In the description of this video is all the information about the roundover bits and what you need to be looking for when you're getting roundover bits. You have to have the form tool set up properly in the database. If you're going to get the IDC Woodcraft database, be sure to get the IDC Woodcraft roundover bits, because it will not work with other brand roundover bits, because every one of us, the different CNC router bit companies, have different profiles for our roundover bits. And of course, down in the description are links to everything I've talked about, more information about the roundover bits, and other things you may want to look into. If you got something out of this video, please give me a like and a comment down below of what you've learned. And if you decide to work with the roundover bits, one of the most important things to remember is every manufacturer of CNC form tools, which is what a roundover bit is, they're all different. And so with the IDC Woodcraft roundover bit, the 1/4 and 1/8, the specs for that are in the IDC Woodcraft database. You cannot use roundover bit specs from another manufacturer for these bits. So you can't interchange. That's just a dead set rule. You'll run into problems. Remember to look down in the description of this video. There's lots of information, links to the roundover bits, the database, the other things I've talked about. And with that, have a great day, better tomorrow, and happy CNCing. idcwoodcraft.com